This conference will now be recorded.
Hello, everyone. This is Brian Gothel, Weather Service Office of Observations, and this is the Satellite Book Club seminar for today. We hope you're in the right place. Thank you for joining. Before we begin, a few reminders. This session, as usual, being recorded, so folks who can't join can benefit from this anytime after today. And as usual, we'll be taking Q&A after the presentation, and everyone is encouraged to put your questions in the chat room, and the TOWS team is here to help the facilitators and the speakers work through your comments and feedback that we hope you'll put in the chat room. As usual, today we're looking for presenters for future seminar series. We're continuing our weekly lineup, and we've got a series set up through the rest of this month and through August, but we're always planning ahead and interested in sharing what folks have to present in the way of satellite data exploitation for forecasting. So contact the TOWS team. Their contacts will be here later on. We'll put them up on the screen. And also in the emails that are TOWS emails that are sent out for the book club has contact information, Kashad Bowman and his colleagues. For future presenters, there is help available both from the TOWS team and the training group to help develop and provide the training materials that might not be available today. And Brian Mata is the focal point for that. As usual, thanks to the TOWS team, Kashad Bowman here and his colleagues for pulling this together. Thanks to the presenters, to OCLO, a GOES-R program, and JPSS, and all of you attendees. A few words about our speakers today, Dan Bykos and Jim Ledoux, for those who might not know them already. Dan's been involved with operational satellite training since joining CIRA at Colorado State back in 1998. He's developed numerous visit training sessions as well as Satellite Hydrology and Meteorology, SHyMet training courses. He received his BS in meteorology from SUNY, Brockport, and an MS also in meteorology from Oklahoma. Joining Dan is Jim Ledoux, who's been a master's instructor at the Warning Decision Training Division for 25 years, where he specializes in teaching severe storm interpretation, winter and summer severe weather warning decision making, and damage surveying. Jim leads the warning operations course for winter and has developed training for tornado warning decision making. His other activities includes chair and founder of an engineering standards committee on wind speed estimation, as well as AMS ad hoc committee on engineering resilient communities. Jim has his BS from SUNY as well, SUNY Oswego, and an MS in meteorology from the University of Oklahoma. Please join me in welcoming Dan and Jim to the Satellite Book Club. The floor is theirs.
Thank you for that introduction, Brian. The title of our presentation for today is Data Fusion Techniques for Operational Forecasting and Warning Decision-Making Applied to Severe Thunderstorms. And I just want to say this is work between Jim and myself. However, Jim is unable to join us for the webinar today, so I will be leading us through it. First of all, what is data fusion? It's something forecasters have been a beneficiary of for as long as NWP has been around. Data assimilation represents the ultimate level of data fusion where all environmental observations contribute to a single analysis. The most important consideration in assimilation is producing a stable analysis. Imagine NWP without satellite data. For anyone worrying about the importance of polar satellite data, one view of this plot should alleviate their fears. It's ostensibly the single most important information source for the global models. Data fusion even means taking NWP data and assimilating it to create an analysis. The no-risk snowfall analysis takes in the HER as an input to build the background, or if there's no other information sources, it's the primary. But actual observations make up a significant portion of the no-risk analysis when and where available. The no-risk takes in a lot of information and actual observations, but sometimes the analysis doesn't agree with the observations. This is your chance to determine if the analysis is wrong. You may know that a certain observer to be credible and no need for a buddy check system, or you know that an observer tends to inflate the observations because of a past record compared to their neighbors. Prob Severe is a Bayesian based probability model of the likelihood of a hail, wind, or tornado LSR from now until 60 minutes in the future. It takes analysis data and storm attributes from radar, lightning, and satellite. You'd think of this as the ultimate in data fusion, and in some ways, it's the best guidance there is for a warning forecaster pressed for time, but it represents just the start of a statistical guidance. More advanced AI versions of this guidance is coming. But there are limitations that you can use as targets of opportunity to improve your estimate. Knowing the limitations gives you a direction in which to change the probabilities based on your own analysis of the data it used and more. Data fusion is really about applying more than one type of weather information to answer a forecast problem or question. There's numerous forecast problems. We just talked about assimilation being one of them. We need the best analysis from which to begin forecast production. Forecast problems are maybe too numerous to count here, but we can narrow down the forecast problems by what kind of job function you're inhabiting at the moment. Why use data fusion in warning operations? Well, you want to overcome data constraints. An example of that might be radar range limitation. Compensating for data quality issues. An example of that might be a radar outage. So you're going to need to rely more heavily on GOES, lightning, social media, pictures and video, and so forth. Increased confidence in evaluation. An example of that would be looking for multiple data sources that show the same trend. Anticipation of needed data sources. In other words, which data sets are needed for a given forecast issue. Let's go ahead and look at an example from Hawaii, where the main forecast question here is the precipitation. Where is it falling? In this particular case, heavy precipitating clouds are observed north of Hilo and offshore. This marine warm rain system is common in Hawaii, and there's no radar available close enough to observe it, despite there being two 88Ds on the island. The GOES satellite at this time depicts the cloud band associated with the rain. After some assumptions of continuity, a forecaster could analyze the precipitation along the band, perhaps enhancing it a bit where the cloud band appears more opaque. This simple data fusion process helps take what pieces of information there is to make a precip analysis. No doubt the analysis is less certain, given that the assumption is that where the marine cloud lies, precipitation falls. The WFO likely has more access to polar microwave data to observe precip falling in these clouds at other times, but similar environments. And of course, rain gauges help to fill in the picture for those places onshore, but the strategy is similar. Of the information you see here, several considerations come into play. The strategy to using the right information to answer a forecast problem involves these four considerations. The most important and seemingly obvious first step is knowing what role you're in and the forecast problem at hand. For each forecast problem, there are embedded questions to answer. Here it's simple: where's the rain falling? The first consideration is anticipating available data sources. It means knowing what information you have available and planning to be able to use it. This consideration may depend on another one, what data strengths you have in the potential sources you have. Here, knowing that you have an environment populated by shallow precipitating clouds, you may know that radar data will be of no value. That's not an error by the radar, simply a constraint due to beam blockage and elevation. So now you know that you'll depend on local cams, rain gauges, and satellite data. The gauges have their own constraints as well. They're point observations and on land only, but a local cam provides a visual confirmation of rain falling. Satellite data has constraints. The visible data here is diurnal, of course. So if you're at nighttime, you'd be in need of IR imagery or even the nighttime microphysics RGB. Next is this confidence in evaluation. This means that for some forecast problems, you may have more than one source available to help assess confidence. We're a little thin here with just 2 sources, but at least the CAM and the satellite showing an enhanced cloud band. Finally, there's data quality issues. Perhaps the CAM timestamp is incorrect. At night, you may have the GO17 loop pipe heat issue, which can cause interference in the IR data. So know what situations are likely to create data quality issues. RAOB soundings are supposed to be ground truth, but sometimes they need confirmation. Yesterday, the Minneapolis sounding reported a 500 millibar temperature of -17 up here in the upper left. Yet the ACARS sounding over here in the upper right didn't have nearly as cold of 500 millibar temperatures. ACARS and the nearest NewCaps sounding available down here in the lower right, that was from 8Z, but they both had 500 temps of -11. So data fusion helps create consensus to either boost confidence or, as seen here, increase uncertainty where needed. Let's talk short-term forecasting and warnings for convection. What forecast problems are there? We have a bunch of these listed here. I'm not going to read them all, but some of these may apply. And with each one, there are tasks that need answering questions. Data fusion has its challenges. Any warning forecaster has incoming data from multiple observing platforms, social media, spotters, NWP, and more. At the same time, each source has its changing levels of data quality, potential outages, and constraints. AWIPS provides every forecaster a huge assortment of products. Just from GOES, radar, MRMS, and lightning, there's hundreds of products. So it becomes a question of which ones do you pick. Many products can be grouped together because of the similarity of the information they present to answer a forecast problem, but sometimes uniquely different information sources presenting a similar picture of a forecast problem can be useful to boost confidence. What we're going to do is look at 9 of those and look at them in an illustration here in a 9-panel display. So I'm going to switch my presentation to over here. And this is a loop of a 9-panel display. So imagine we've chosen some data to look at here. At the top row, we have satellite data, the visible 1.6 and IR across the top. Then we have MRS products in the middle, rotation tracks and so forth. I'm not going to go into details on all of them, but I want to point your attention to the southernmost portion of this line where this yellow arrow is, and your first question here will be convective initiation. And one of the more useful data sources to assess that would be looking at the satellite data up here, and particularly when do you start to see glaciation at cloud top. If I advance the loop here, we can go ahead and check when that's occurring. So I'll go ahead and let this play. So we start to see, as this goes along, you can see trends over here on the left. In the actual imagery, you begin to see convective initiation taking place. You see cooling cloud tops. You see decreasing reflectance at 1.6, indicating glaciation has occurred. And then you begin to see higher reflectivity aloft, lightning indications here. We get into the warning decision making period here, and we see signs of a splitting storm. We see new updraft pulse on the right mover, which signals intensification. And then finally down here in the mesh, we see indications of 1-inch hail. And then maybe we're getting into the severe versus tornado warning decision, and we see indications of a mesocyclone. So this would be kind of a classic example of looking at multiple data sources and looking at trends as well as kind of combining all of them together to get one picture in terms of maximizing your situational awareness. So let's go back to here. This is a timeline of events taken from a storm from a case used in one of the data fusion exercises. Storm scale signatures are observed from GOES imagery along with trends in lightning data that can compensate for data quality issues. In this particular case, the nearest radar went down and there were issues with the Earth network's lightning data in AWIPS. The cumulative effect of observing multiple storm scale signatures from satellite along with lightning trends and environmental data provides confidence in the warning decision. And the warning decision in this particular case came here, and a little bit later the tornado report came along. So that's another example. Okay, now what training is available out there currently on data fusion? And I apologize if I missed out on anything here, but this is what Jim and myself came up with. What we're going to talk about mostly is the warning operations course, in other words, the WALK severe track, the FY21 version that came out earlier this year. I'll talk more in detail about this later. But before I get to that, I want to point out there's been numerous webinars out there that take a data fusion approach. In other words, combining multiple data sets. I'm just going to list an example of some, not an exhaustive list of some of the webinars out there. First, the FDDT webinars. David Levin from Juneau did a really nice webinar on issuing warnings with no radar. It was a storm in the panhandle of Alaska that was just too far from radar. So he was looking at all other data sources essentially and issuing a warning for that. Ashley Ravenscraft and Chris White put together a nice webinar utilizing GLM in the severe warning process. So making use of that, particularly if you have issues with radar being down. Randy Bowers from Norman did a webinar on the importance of mesoanalysis, really looking at everything, doing a nice job in terms of mesoanalysis. There was a previous SBC webinar. It was really a panel discussion with several folks, and they were looking at situations with a lack of radar or the radar being down. And then finally, WDTD webinar led by Jim, where we looked at this case across Phoenix, and this webinar kind of evolved into the case that Jim implemented into this WALK Severe course. So I encourage you to check out those webinars if you'd like to learn more. So now we're going to look at that WALK Severe course. It's on the LMS, but I want to just highlight how it looks on the web pages, which are listed here at this URL. First, just click on the Data Fusion section to expand, and what you'll see is a satellite section. This includes visit training sessions by myself, the storm signatures, from satellite, and also the integrating GOES into mesoanalysis. And then Scott Lindstrom put together this above anvil cirrus plumes training. And then there's a lightning and prob severe sections with content you can check out there. And then the section I'm going to most focus on is the practice and applications from multiple sources. So I'm going to take this and blow it up here on the next page. This first item, data fusion and short-term severe local forecast and warnings. This is developed by Jim. He looked at that Arizona case that developed from that webinar initially. It was a night case with low-topped severe thunderstorms, and the primary objective was to look at or evaluate the utility of multiple data sets for frontal analysis, updraft intensity, and low-level vorticity. And then case number 2, this data fusion exercise case, I led, and it was a Colorado case with a radar outage at really the worst possible time during a significant severe weather event. And the idea or the challenge was to maintain situational awareness during the WNDM process to overcome data quality issues. So for both of these cases, we used a scenario approach with questions, And near the end, we had an expert walkthrough, and that included Q&A as well. What's upcoming for data fusion training in FY21? We're currently working on a session for low-topped severe thunderstorms. The challenges associated with low-top storms include relatively smaller and shallower storms, which make sampling more difficult with radar and satellite imagery. Also, the lightning activity is generally less or maybe even non-existent. So for these reasons, data fusion is crucial and offers the best chance of maintaining situational awareness. This training will be delivered on the CLC and also available on the Visit website. In summary, data fusion enhances confidence. Data fusion compensates for quality control issues. Also, you have the challenge of too many products to look at. So you really need a strategy to cull the data to what you need to address a forecast problem. And we have just a limited amount of time here to talk about data fusion. Of course, there's a lot more to discuss, so just refer to the data fusion courses that I just talked about for a deeper dive into the topic of data fusion. Thanks very much, and that's all I have.
All right, thanks, Dan. We are going to pass it over to Caitlin Rutt, who is our facilitator today. Caitlin, I'm sorry I neglected to introduce you at the beginning. Caitlin's our facilitator today, and she's going to be leading us through Q&A. I want to remind you to leave your questions and comments put your questions and comments in the chat, and Caitlin will be walking us through the Q&A as they come in. Caitlin?
Thank you, Brian. So I just want to encourage everyone to stay on for the discussion. And also there's a feedback survey that Leah just posted in the chat room. So feel free to head over there and give some feedback to the TowerS team. Also in a week from today, Thursday, July 22nd, this is at 1 p.m. Normally it's at 12 p.m. Eastern, but at 1 p.m. Eastern, Chad Gravel from Southern Region Headquarters and Jordan Rabinowitz from Eastern Region Headquarters will discuss the GOES-R MMM tool. And again, that will be at a different time next week. That will be an hour later at 1 p.m. Eastern. I also encourage attendees to contact the TowerS team, both Lee Byerly and Kashad Bowman, for questions about the Satellite Book Club or for configuration of satellite products. More information will follow also in an email from the TowerS team. All right, so we'll head right into some discussion. One of the first questions that I know Dan and Jim were wondering from the people who are listening, especially those that are in offices, they were wondering if there was any way you could provide any examples or events in which you use data fusion techniques in your own office. Where has it come in handy? So if you want to add those into the chat and want to answer that to help them out, that would be really, really helpful. But we do have one question, and we'll start. Looks like Ross has asked, what are the best practices for data fusion?
Yes, great question, Ross. Really three things, and it's covered in the training that we have. First is practice. Just get into that routine of practicing data, looking at multiple data sets. It's always a good idea. You never know if the radar is going to go out for whatever reason. Be looking at the multiple data sets, kind of integrating them, giving you a better situational awareness of what's going on. Number two would be postmortem. Look at this from a postmortem exercise type of, maybe you didn't have time to look at everything as the event was unfolding. So in a postmortem sense, you can go back and maybe look at all the data sets and say, okay, yeah, that's where I could have used this. Another important attribute to that is training. Maybe making sure you've taken enough training on the different observational data sets that are out there. Maybe you learn a little bit more about some of the constraints or some of the constraints or some other things that are covered in training. So I would say those three things: practice, post-mortem exercise, and training.
Thank you, Dan. Looks like Sheldon has said, excellent talk, Dan. Does data fusion also mean overlaying different data at the same projection and resolution on your AWIP screen and then looping them?
Yes, that definitely includes that. And an important thing to remember when you do that, like I showed there in that 9 panel, but I didn't specifically say it, is remember to account for parallax. If you're looking at, say, radar along with storm tops in the satellite imagery, you're going to need to account for the parallax in the satellite component just to make sure they match up there. You have to mentally do that. So yes, doing that whenever possible is a great idea, Sheldon, and just remember to account for parallax.
All right, thank you, Sheldon. I'm not seeing any other questions coming in the chat. If anyone else has any other questions or wants to also give an example in which they've used data fusion in their own office, that might be really helpful for Dan and Jim with this research. All right, I'm not really seeing much more coming in. Thank you, Dan, for this presentation. It was really enlightening, and I know as a person who works in an office as well, I'm using data fusion all the time, so it was very good. Thank you.
All right, thank you.
All right, then, if no further questions for Dan, I want to echo Caitlin's thanks to Dan and Jim, and again to you, Caitlin. Thank you again for facilitating. Caitlin's from WFO Amarillo, and so I mentioned we're looking for future speakers. We're also looking for future facilitators, and field reps are more than welcome to work with us on these future seminar series. So please contact the TAURES team if interested. And so thanks all of you for your participation, and we look forward to you joining us again next week. We'll be starting 1 hour later next week, but the seminar series goes on a week from today. Thank you very much.